All right, so in this problem here, we're attempting to sketch the graph of a rational function. Remember, rational functions are functions which can be written as a fraction of polynomials. So 2x plus 5, that's a polynomial. X minus 8, that is a polynomial. And they're dividing each other. When you're trying to graph a rational function, or when you are studying or working with any rational functions, it's important to know the various features, such as the uh, X-intercepts, the Y-intercept, its vertical asymptotes, which is a very distinctive feature about rational functions, as well as its end behavior. Let me make this a little bit thicker. So to find the x-intercept of any function, really, what you're doing is you're trying to solve for the x values, which go into f, right? You're trying to solve for any x values where the function is equal to 0, right? So to find the x-intercepts of this function, we are going to set it equal to 0. So we have 2x plus 5 over x minus 3 equals 0. Now, if you're trying to solve when this fraction equals 0, what's great is that we can actually multiply both sides by the x minus 3. In order to get rid of it in the denominator. And so that goes away, and 0 times anything is still 0. So as a result, we get that 2x plus 5 equals 0. So what would x be? It would be negative 5 halves. That's the x-intercept. In reality, when you're trying to find the x-intercepts of rational functions, it'll just be when the top part equals 0, right? Because the bottom part, we can always just multiply it over like we did here. Y-intercepts for any function, that's just going to be the function with 0 plugged in, right? So when I plug 0 into this function, I get 2 times 0 is 0, plus 5 is 5 on top, and 0 minus 3 is negative 3. That's my y-intercept, right? So negative 5/3. Vertical asymptotes are a little different. Vertical asymptotes are the result of division by 0, right? So if you ever have whatever here, you have anything up here, and then you have 0 on the bottom, right? So we're looking at x minus 3. When does x minus 3 equal 0? Well, that would be when x equals 3. And finally, end behavior. Now, end behavior is a little bit interesting with rational functions. Essentially, we're just trying to see as x gets very big, or as x gets very negative, right? As it goes to infinity or negative infinity, what's this function going to go towards, right? The way that you can find end behavior is you actually just, you can look at the leading terms, right? So 2x and x. If I take the leading terms and divide them, I will find that my end behavior is 2. So let's see what this all looks like put together into a graph. We'll graph it over here. So first off, let's plot our intercepts. We have an x-intercept at negative 5 halves. So here's, and you should label this negative 5 halves. I have an x-intercept. I have a y-intercept at negative 5 over 3. So here's negative 5/3. I have a vertical asymptote at x equals 3. So here we'll make, this is x equals 3, right? And vertical asymptotes, we tend to show them as a dashed line, right? And then finally, the end behavior. The end behavior is going to be 2. And when we talk about end behavior, guys, it's actually a y value. It's y equals this. So up here at y equals 2, I will have a dashed line from my end behavior. And we have all the features that we need in order to get started. So what we're going to do is the following. I'm going to start with my y-intercept. Now, the reason why I'm starting with the y-intercept is because just like when we graphed higher degree polynomials, I need some point where the y value is known and it's not 0. That'll help me get started with my function, because then I know that from this dot right here, as I go to the left, going to go to my X-intercept there. So I'm going to connect that, and it shows me kind of the pattern that's going on. What's going to happen is this is going to extend and go towards my end behavior, right? So you can see that the line is going to plateau towards y equals 2 here. Then as I go to the right, my line should go towards this asymptote here and go downward. So the idea is that the function will get closer and closer to this x equals 3 value here, but it'll never quite reach it. It just goes down towards negative infinity. Then, to the right of the asymptote, if I'm going downward here, I should be coming from infinity up at the other end of the asymptote and go towards my end behavior. So you can see that what happens is this function, it's going down to negative infinity on one end of the asymptote, and it's going up towards infinity on the other end of the asymptote. On the left side, I'm going towards y equals 2, which is my end behavior. On the right side, I'm going towards y equals 2, which is my end behavior, and I've cut through my intercepts. Now that's going to be how you sketch the graph of a rational function. It's important to note, the main reason why we try to be able to sketch these functions is so that we can make sure that we understand how to identify these features. Being able to know these features is very important in topics like calculus, working with functions, and your future math classes.